morning students, this is lecture number 5 of unit number 5 theory of machine. Today we will start second classification of brake, that is bend brake. This is two types, simple bend brake and differential bend brake. Now we start from simple bend brake. It consists of flexible bend and the ends of bend is pivoted at point O and point B on the lever O, B, C. When P external load applied at point C, the lever OBC moves or turn around point O. This is fulcrum point. Now on all the bend brakes condition, we assumed T1 and T2 bend sides are perpendicular to the lever OBC and neglect obliquity effect. In bend brake, T1 tension in tight side, T2 tension in slack side, theta angle of lap of bend wrapped over the wheel, mu coefficient of friction, r radius of drum, t thickness of bend, re is effective radius including thickness of bend. So re is small r plus t by 2. Here t is the thickness of bend. Now very important consideration is when wheel rotates in clockwise direction. So the sides from which bends entering like this side and the sides the bend leaving like this side. Okay, the sides from which bend entering is called tension side or tight side. So this side is known as tight side, and at this side the tension acts T1, tension in tight side. When bend leaves here T2, so T2 is tension in slack side. Okay. When wheel rotates in anti-clockwise direction, in this case bend entering from this side and leaving from this side. So when bend entering at this side, so this side is known as tight side and tension T1, and when leaving the bend from this side is known as slack side and having tension T2. So this is very simple concept. When bend entering at this side, so that side is known as tension side and having tension in T1, and when leaving the bends, that side is known as slack side and tension as T2. Now in simple bend condition, first determination of limiting ratio of tensions like T1 upon T2 is equal to e की power mu theta. Here mu is equal to coefficient of friction and theta is equal to angle of lap over the wheel of bend. Here L 2m. This is angle of lap, this theta. Okay. In limiting ratio of tension, here theta is in radian, not in degree. So be careful. If theta is given in degree, like a 90 degree, so it is converted into radian as multiply by pi upon 180 and convert it into radian. Okay, if theta is given in degree, and first it convert to in radian by multiplying pi upon 180. Now second determination as net braking force. Net braking force, this is simply as small capital F. So T1 minus T2 is net or total or effective braking force, T1 minus T2. So we assume T1 as tension in tight side, we assume it's positive, or T2 is tension in slack side or will be negative. So net or total or effective braking force will be F is equal to T1 minus T2. So next, effective or net braking torque, that will be equal to force into radius. Here force into radius, force T1 minus T2 into radius. So this formula is used for when neglecting the band thickness. If we consider the thickness of band, so braking torque will be T1 minus T2 R plus TE. So this formula will be used. Here R plus TE is the effective radius of drum, including belt thickness. So TV is also written as TV is equal to T1 minus T2 into RE when thickness of band will be given. Okay, so RE is equal to R plus T by 2. Now case number 1, when wheel rotates in clockwise direction. So we assumed neglecting the obliquity effects. So T1 and T2 is perpendicular to the lever. Now taking the moment about point O. So taking the moment about point O when wheel rotates in clockwise direction. So P into L, it's make a anti-clockwise couple. So P into L, it's make a anti-clockwise couple, and T1 tension in tight side into B, it make a clockwise couple. So the net sum of couple will be 0. There will be two couple, P into L in anti-clockwise direction and T1 into B is in clockwise direction. So P into L minus T1 into B, the net sum of couple will be 0. So we got a relation P into L is equal to T1 into B. This is used for when wheel rotates in clockwise direction. Now move on second case, when wheel rotates in anti-clockwise direction. So most of the formulas used as previous cases. Limiting ratio as T1 and T1 upon T2 e की power mu theta. Net effective braking force T1 minus T2. Braking torque will be T1 minus T2 into R. T1 minus T2 into R will be used for when neglecting the thickness of band. and T1 minus T2 into R plus T by 2. This will be used for when considering thickness of band. Here R plus T by 2 is equal to RE. RE is the effective radius of drum including belt thickness. Now the differ from previous case by here taking moment out point O. So P into L, it's make a anti-clockwise couple. So P into L, and second type of couple is T2 into B, it's make a clockwise couple. So here two couples generates P into L, it's make anti-clockwise, and second couple is T2 into B, it's make a clockwise. So P into L into T2 into B equal to 0. The moment will be equal to 0. That will be obtained T2 into B equal to P into L. So P into L equal to T2 into B. In previous case, we remember P into L equal to T1 into B. In previous case, we got T1, and in this case T2, because in previous case the wheel rotates in clockwise direction. So band enters from this side, so this side will be T1, and leaves from this side will be T2. Okay, so the second couple in previous case, this is T1 into B. Now in this case wheel rotates anti-clockwise, so band enters from this side, so this side will be T1, and leaves at this side, so this side will be T2. So tension in opposite direction, so this will be T2. So T2 into B will be counted for this condition. So B obtained P into L is equal to T2 into B. The most important consideration is also T1 in tight side and T2 will slack side. So T1 is always greater than T2. So T1 is always greater than T2. So T1 is more than T2. So we consider the permissible tensile stress on tight side and consider the force as T1. So permissible tensile stress sigma is equal to load T1 upon area of band. So area of band is equal to W into T. Here W is equal to width of band and T is equal to thickness of band. So we can see the cross sectional area of band. So this hatching section will be left on wheel. So this will be thickness T and this will be width of band W. So area of band is equal to W into T. Okay. Now move on next. Okay. So here we solve a numerical based on simple band break. So please read question carefully. a band brake acts on 3/4 of circumference of drum. So first here, please see 3/4 of circumference of drum. That means it gives theta. So theta is 3/4 into circumference is 360. So theta is equal to 3/4 into 360 in degree, but we will use theta in radian. So it converts degree to radian by multiplying by pi by 180, and we get the value of theta in radian. So 3/4 into 360, 3/4 into 360 and pi upon 180, and got value of theta is equal to 4.712 radian. Okay, now move on second given data. The drum of 450 mm dia. The diameter of drum is 450 mm and radius will be 2 to 5 mm. Now move on. Which is keyed to the shaft? The band brake provides a braking torque of 225 Newton meter. So here braking torque. So please note it here. Braking torque T is equal to 225 Newton meter. Now move on. One end of band is attached to a fulcrum pin of the lever. So one end is fixed to fulcrum lever at point O and other end to a pin 100 mm from the fulcrum. So this is the other end. So this is 100 mm from the fulcrum point O. So here B is given. So B is 100 mm. So B is 100 mm. Next here, if the operating force is applied at 500 mm from the fulcrum, so applied force P is here and the distance from the fulcrum point is L as 500 mm. Okay, now move on. Coefficient of friction is 0.25. Coefficient of friction of 0.25. Find the operating force when drum rotates. First case clockwise direction and second case will be anti-clockwise direction. So by using the given data, first determination will be limiting ratio of the tensions T1 upon T2 e की power mu theta. So putting the value of mu as 0.25 and theta as 4.712 radian. Please carefully putting the value of theta in radian, not in degree. Okay, so T1 upon T2 e की power mu theta, putting the value of mu and theta, and we get the value of T1 upon T2 as 3.247 and we mention as equation number 1 here. So T1 upon T2 is equal to 3.247, equation number 1. And next consideration as or net determination, braking torque. So braking torque is equal to TV equal to T1 minus T2 into R. Here R is equal to radius of drum. So we know the value of T. T is 225. So put the value of T here is, and radius is 225 mm. So putting the value of TV and R in equation number 2. So 225 equal to T1 minus T2 into 0.225. Here R in meter. So 225 equal to T1 minus T2 is equal to 0.225. So we get T1 minus T2 equal to 1000 Newton. So T1 minus T2 equal to 1000 Newton, and this gives equation number 3. Equation number 3. Okay. From equation number 1, T1 equal to 3.247 T2. From equation number 1, T1 equal to 3.247 T2, and putting the value of T1 in equation number 3. So putting the value of T1 in equation number 3, we got the value of T2 as 445.03 Newton. This is the exact value. Now the value of T2 again putting in equation number 1, and we got value of T1 as 1445.01 Newton. So by using limiting ratio equation and braking torque equation, we got value of T1 and T2. So T1 is 1445.01 Newton and T2 is 445.03 Newton. Now move on determination. Find the operating force when wheel rotates in clockwise and anti-clockwise direction. Now, first case, when wheel rotates in clockwise direction. In figure 1, the taking moment out point O. So P into L, it moves the anti-clockwise couple. So this will be positive. And second couple makes as T1 into B. It's make a clockwise couple. So clockwise couple assumed as negative sense. So P into L minus T into B equal to 0. So putting the value of L and T1 and B in this equation. So P into 500 equal to TB into B. So TB is equal to 1445.01 into 100, and B get the value of P. So P is 289 Newton. So where P is equal to 289 Newton when wheel rotates in clockwise direction. Now in second case, when wheel rotates in CCW. CCW means counter-clockwise direction or anti-clockwise direction. So in figure 2, this. So P, this is P. So P into L, it's make a anti-clockwise couple. So anti-clockwise couple assumed as positive sense. So P into L, and second couple is T2. Okay, so T2 into B, it's make a clockwise couple. So clockwise couple assumed as negative. So P into L minus T2 into B equal to 0. So putting the value of T2 from here, B is 100 mm and L will be 500 mm. So P into L minus T2 into B is equal to 0. Putting the value of T2, B and L in this equation, and B get the value of P. So P is 89 Newton when wheel rotates in anticlockwise direction. Okay.